Okay, here we go. I'm going to have to talk fast so we aren't late for the assembly, but here's the question. This is, which question is it? 13C. Okay. Now, hands up, have you got it? Anyone? Yeah? Okay, alright. Now, it's doable, okay? But it does look weird, especially this guy. Okay, so I'm going to walk you through a strategy of how you would do it. Now, most people, the default way is you're going to start with this left-hand side, which is fine. Okay, left-hand side equals, and then you differentiate, and you use quotient rule, providing you remember that it's a quotient. And then you should end up with, when you've got your u and your v, and you resolve it all out, I think you get down to this. I think that's what you get down to, okay? Now I could go a little further if I want to, okay? Because this will become cos squared minus 2 sine x cos x plus sine squared. You're like, I've got a cos squared plus sine squared there. That's good. So they equal 1, and you're left with a 2 sine x cos x, which you can also simplify. It becomes sine 2x. Now, ordinarily, I think that would be better. Okay. However, we're not just trying to simplify mindlessly. We're actually trying to get through something specific. And getting a sine 2x down here, 1 plus sine 2x, is not getting us toward this at all. Okay. Now, admittedly, when you get down to this, you're like, what do I do? How on earth do I introduce a pi on 4 in there, okay? So I do not blame you if you look at this spot and you do a dummy spin, okay? However, the reason why this is they give you the result and they say, okay, prove this, is because they're trying to lead you toward a particular direction that you would not usually guess on your own. So here's the way that I would approach it, okay? I'm stuck at this point. So I'm going to say, if I can't go any further on the left, let's see what I can do with the right. Now, just be careful with this. I'm going to give a caution for this, that what I'm going to write on this side is not part of my proof, but it's me trying to work out what kind of steps can I take. So sec squared, okay? We know that sec is 1 over cos, okay? So this is really this. Okay? Now that in turn is really this. Let's see. So I've got cos pi on 4 plus x, and that whole thing is squared. Okay. Now that's promising. I've got something over something squared. That's already looking like I'm sort of on the right track. So these things should connect. Okay. Now I have two terms here, two wave functions, and I only have one here. Well, you guys know how to turn 1 into 2. You're going to expand. Just use the regular old expansion. So you're going to get, what's inside here? This is cos A plus B. So you're going to get cos minus sine. Yes? Right? So then you just fill in your values. You'll have pi on 4, x, pi on 4, x. Okay? But both of these are equal to 1 on root 2. So I can factorize them out. 1 on root 2. Cos minus sine. That's suspicious, isn't it? Okay. Now, that root 2 there, that's going to become a half, but when you divide by a half, you're really multiplying by 2. Now, remember I said, this is not my proof. At this point, you cannot go home and say, you know, I'm done, I've proved it. Okay? Because what they're really saying is, this statement here is like saying, look, get me from A to B. Okay, this is what I was saying before, right? You would fire a taxi driver if you said, get me from A to B. And he's like, yeah, it's cool. I'll meet you there at C. And, you know, pay me $80, right? You need to get from one side to the other. This is not enough. However, getting from one side to the other is just taking this and putting it in reverse over here, right? So you would do this. You'd go, well, that's 2 over 1 on root 2 cos x minus sine. Now, hold on, so it's 1 all squared. Now, hold on a second. You're like, never in a million years would I think of putting that 2 down here as a square root and then squaring. Who would think of doing that? Answer, you would if you knew this was where you had to end up. So you're going to continue putting the rest and end up there.